In this video, I will address a common point of confusion. What happens when we use quantifiers with the empty set? If you haven't watched the previous video, Simple Proofs with Quantifiers, I suggest you watch that one first, because I will be referencing it. I will put a link in the description. Have a look at these two statements, and be careful because there is a trap. The first one says for every x in the empty set, x is positive. The second one says there exists x in the empty set such that x is positive. One of them is true, one of them is false. I invite you to pause the video, think about them, decide what you think, and only after that, continue watching. I've seen statements like this before. For every x in a set, x is positive. So I'm going to focus on number one first and look at what I learned in the previous video. In the previous video, I proved that for every x in this set A, x was positive. And then I disproved that for every x in the integers, x was positive. How did we prove it was true that for every x in a set, x was positive? We verify all the elements in the set. We went through them one by one and checked each one of them was positive. How did we prove that for every x in a set, x is positive, that this is false? We found one single element that was not positive. So either check all the elements in the set as positive or find a single one that isn't positive. So let's try to do that with the empty set that has no elements. I'm going to refer to this part here, x greater than 0 as star, and I'll explain why in a moment. And let's see what I have learned. To prove that for every element in a set something, to prove that's true, I need to verify all elements in the set satisfy that thing. Notice it doesn't say to find one or many. You need to verify all the elements in the set satisfied. So if the set has 3 elements, check all 3. If it has only one, check that one. If it has infinitely many, check all of them. If it has 0 elements, then check all 0, which means don't check anything. On the other hand, if I want to prove that it is false for every x in a set something, I need to find one element. No matter how many elements are in there in the set, I need to find one element that doesn't satisfy the condition. So think of it from this perspective. Which one of these two things can I do? And I hope it's now clear that I can prove it's true, but I cannot prove it's false. I can prove it's true because I can check all the elements in the empty set. There is nothing to check, and all of them satisfy that. Since there is nothing to check, I'm done. But I cannot find one element in the empty set with that condition, because I cannot find one element to begin with. So this is good. We are able to prove it's true, and we are not able to prove it's false. So those two things are compatible. Good. And therefore, the first statement is true. I know some students prefer to focus only on the second thing and say it's true because I cannot prove it's false, but I think it's useful to look at both perspectives. We are able to prove it's true, there is nothing to do, and we are not able to prove it's false. And after looking at this, it should also be clear that the second statement is going to be false. There is not much more to do there. Now, the moral is, and I hope you have noticed, the reason I call this star, is that it really didn't matter what this condition was. The exact same argument could work. So in general, any statement that begins with, for every x in the empty set, whatever, that's going to be true. And any statement that begins with, there exists x in the empty set such that, whatever, that's going to be false.